Okay, thank you for the invitation. So what I want to share with you today is how we're thinking of leveraging container technology in an EU project that we're also doing, and it's 1 year that we started. It's a Process EU project, and the idea of this project is at least kind of providing computing solutions for exascale changes. So it's one of these many other exascale projects, EU-funded projects. And for us, it's trying to find a way how to leverage all this container technology and see what's different from the past and how we can make life better for scientists. So the challenges that we have in front of us, we have from two parts. It's kind of challenges from the resource part and the challenges from the application part. So the resources, as you can know, they're very heterogeneous. The resources out there, like the HPC, you have the cloud, and they have different stacks, and they have different data ingress, different protocols, where everything is different about them. So how to get them work together, it's a big challenge. At the same time, from the resources, you have the data that's everywhere nowadays, and all the applications are data-centric. You have ownership of the data, that's an issue. You have the ways you can move data from A to B, that's a big issue, and the size of the data, that's becoming an issue. And since the project is about exascale, if you think about an exabyte of data, the 100 gigabit connection, it takes around 3 years to move that. So that's the idea that we're working towards. From the application point, you also have all these challenges that applications, contrary to, I guess, 10 years ago, they're becoming more complex. Like the pipelines are more complex, they're more data-centric, not simulation, and they depend on hardware, different hardware, so there's a big variance in the applications. Portability is an issue because scientists are collaborating together. So these are the challenges that we try to address parts of these challenges in this project, and we think of containers that can help us do this. We go a bit, turn back time and go a bit in the Grid era. I think many people would recognize the hourglass that from the Grid era. You used to have applications, and then you had a kind of monolithic approach that you had a middleware, and then you had all the grid resources around Europe. And the middleware idea was one middleware, like G-Lite, whatever, connects everything together, and in a utopia, all these applications, we access one middleware and they access all the resources, and we're all happy. But what we have kind of now is that everyone develops his own applications, own workflows, has his own frameworks because of the dependencies and everything, and they're tied into their own resources. So they might have on-campus on-campus clusters, and they're gonna use the applications there on their campus. And if they're using cloud, most often they're gonna get jailed in a provider system that can move out data, move in data. So there are all these challenges that we have to work with. So you see, like the middleware has kind of disappeared from what it used to be like 10, 15 years ago. So the idea now is how can we make life better? So if we take a look at what resources are out there, when I talk about resources, it's the compute, the data, so HPC, cloud, and the internet. So you see there's a big variance, and you have like cloud and HPC, and you have firewalls, and you have all these all the means you can access these resources, like different job queues, different access credentials, different protocols, everything is different. So working together is not a simple task. Different different technologies also. So, with containers, also container technologies, you have different approaches. So you have Docker and you have Singularity, and all the sites are using different approaches for this. From a networking point, you also have stuff like you have Giant in Europe that it's giving high bandwidth through the European network. But what we get is when the scientist tries to use this, it has to figure out maybe how it's going to combine everything together. So it's going to, because the scientist is a poor scientist, he's going to use resources that's given to him, and most of the time he's going to get some resources from here, some other resources from a different institute. Is collaborating, so has this. So at the end, it's going to map a workflow on all this, and it's going to be a big headache. So if we just look a bit about the container technologies that are out there, and we already had an introduction about them, so I won't spend a lot of time dwelling on this. But what you have is basically VMs, and for virtualization, then you have container technologies like Docker, and then simpler, easier container technology like Singularity. And Singularity is meant for more HPC stuff, and Docker is more cloud stuff, and virtual machines are virtual machines. Running some tests, I think I'm kind of the same conclusions as Mariano, that okay, Singularity, they can get close to bare metal in many applications, so they can be good for performance. So our approach, how can we, what can we bring to the table when we're thinking about all this is, when I think of the applications and the resources, how can we combine them through containerization. The idea is that instead of harmonizing everything and everything has to be the same, our approach is kind of adaptability. So the application can adapt to the changing infrastructure, changing resources by changing, by creating containers and infrastructures. So if we think of it, if we go back to what a workflow in simple terms is, you have a workflow and you have some tasks that are depending on other, and you have staging, and you have task one, and it's running all this, all the tasks are running dependent on the others. And around a workflow, usually we would have a workflow management system that's coordinating everything. That's like traditional approach of kind of workflow management systems. We have a stage in out phase, a stage in and a stage out phase. So to think of how to get these applications fit onto a diverse infrastructure is trying to create this idea of infrastructures that are application defined. So the application in this case is the workflow, and from this we want to devise an infrastructure. We call it like a micro infrastructure because like container based, and from this we get a small kind of virtual cluster for the application and all the dependencies. So now we talk about not just the library dependencies of the application, but the whole environment is virtualized. So the workflow management system, particular to that applications in there, the tools, the adapters to access the resources are in this cluster. And the idea that this cluster is a unit by itself that can move and deployed on different hardware. So what we're looking at is, okay, so then how can we describe such an application? And from this description, we get a description of this whole cluster for just particular application. And from that description, we start deploying it to virtual resources like using Kubernetes and having nodes and whatever, and having this description of the whole infrastructure, deploy this, and then you get all the benefits of portability and scalability that comes with containers. At the same time, you get application-specific security. The cluster itself is isolated. So I guess we're gonna, through these meetings, we're gonna get other presentations might also go into what Kubernetes is, but we can skim quickly through Kubernetes. So Kubernetes is basically an orchestration layer for containers, mostly Docker containers, and what you can do kind of with such a system is have this notion of hyper-convergence. And hyper-convergence in this area is when you have storage, network, and compute totally virtualized. Then you can programmably move everything around because it's virtualized. So then in these terms, it's called hyper-converged infrastructure. And through this programmability, you can optimize many things. And it's the basics of what Kubernetes does. So basically gets a bunch of containers, programs them, and moves them around, and get the networking between them. So if you think of it, something like Kubernetes, you start from your hardware. What hardware can I use? So nodes, laptops, whatever. You bunch them together. You plug in storage also, you bunch everything together and install all this Kubernetes middleware on this hardware, and it starts configuring everything for you. Storage, networking between your containers. So it takes the headache out of everything, and then once you want to run your application, you describe your application into a bunch of containers, group them together into terminology in Kubernetes. They're called pods. So you create a pod is like multiple containers stuck together, and then you create deployments. And deployments you can create like how you want to scale, and all these and all these policies that can go into a deployment. So so our task, I think, in this project is okay. So the application has its own set of containers. So what are like the minimum set of containers that we should surround an application to make it work on different infrastructures? And some of the services that we're developing for like container services are like data staging services. So an application needs staging. So if an application has its own cluster, it needs some staging service. It needs data adapters. So it has remote data on Grid FTP sites. It needs to do like Grid FTP to Grid FTP copying, so we need to manage credentials there. To access like HPC resources, you need some compute offload. So you would have like resources that are submitting maybe Singularity containers onto HPC to offload the compute, and all these. So in the project, we have a few use cases, and a couple of them we're thinking of how we're setting up. So one of these like a medical artificial neural network use case, and then the same idea, like the minimum cluster that's being set up, a virtual cluster for this. You see a bunch of containers. Could have like portals on it, like Jupyter, Nextcloud, whatever, because since everything is containerized, you just bunch in whatever the user wants, functionality for his application. At the same time, another use case would come in and might have different requirements. So just build a new cluster, virtual cluster for different use case. In this case, we have another use case from LOFA, which is processing satellite imagery. And then it has different staging requirements, so it needs to get all these images from tape drive. So the staging in is complex, so it needs a device staging in for that particular use case, and you can containerize the whole workflow in this way. The vision, I guess, is what we end up with is having a programmable layer sitting on top of kind of fast network like Giant that can move data as fast as is technologically possible. And the programmable layer has interconnects into the different resources. So the user would program this programmable layer like a Kubernetes layer, deploy his application as a workflow there, and through there can access the different resources that he has credentials to. And this is something we're working towards. So this is all a work in progress approach. And if we go back then to the hourglass of the Grid era, then what changes? So what's the new middleware? And what we think of as the new middleware is this programmable layer. So this idea of software like Kubernetes and helper software around it that will fill up the middleware layer that will map applications to resources. So that's all from me.